Okay, hopefully you've had a chance to go and convert degrees to minutes and seconds and vice versa, convert some degrees to radians, radians to degrees, and now we're ready to go on to look at some of the formulas that we're going to need to use when we work with circles. So we got that circumference is pi d or 2 pi r. Our arc length is r theta, where theta is an angle, and this angle must be in radians. So we rotate through some angle. That distance there is what we call S. Okay? Now, we're just going to give you the formula that the area of a circle is pi r squared. Okay? And what we want to do is we want to look at the area of what's called a sector. Now, a sector is just a fancy name for a piece of pie. We want to find the area of that piece of pie. Okay? And we saw before that circles have this nice proportionality problem or property that if I take the ratio of this, this is exactly the same as the ratio of the angle and the angle going all the way around, which we showed was 2 pi. So if we do just a little bit of algebra again, multiplying up by the area of a circle, we get the area of a sector is the angle times pi r squared, not 2, just pi r squared, divided by 2 pi. And if you look, the pi's will divide out, and we get that the area of a sector, I'll write it here, and I write myself a little note so I can see what it looks like. It's 1/2 r squared theta. Okay? So to find the area of this piece of pie, I take the radius squared, multiply by this angle, it must be in radians, and then divide that number in 2. That will give us the area of the sector. Okay? Now, two things we want to think about next is motion on a circle. Motion on a circle, we have to think about speed. Okay? And we have speed, we have two different things that we need to consider. Linear velocity and angular velocity. Now, I don't know if you can see the difference in the colors, but linear is going to be going around. This is like if you're sitting on a merry-go-round on the edge. Okay? You want to know how fast you're spinning. Okay? Now, angular velocity, this is how fast the angle is spinning. Okay? Now, there's one other property or velocity that we think about, and we see this a lot. This is RPMs. This is revolutions per minute. Okay? Or really when I think about RPMs, it's the revolutions, the number of times we spin around per unit of time. Okay? So we think about linear velocity. We think of that as distance divided by time. Okay? But as you're traveling around the circle, that's a distance s divided by time. But we know our distance on a circle is r times theta. Okay? Now, angular velocity, and a lot of times we'll use a little omega for angular velocity. This is really the angle that you moved divided by the time. So how many angles you've gone over some period of time. Now, if we look closely, we see this angle over time up here in our velocity formula. So another shortcut for linear velocity is just the radius times the angular velocity. So this is a nice formula to have as you're doing some of the problems. You want to know how fast you're going around the circle. Okay? Now, one last thing, sometimes you have to convert from revolutions per minute to radians per minute, or vice versa. So we'll just do a quick example here. Let's say the merry-go-round, if you will, is going around at 30 revolutions per minute. That is pretty fast. Okay? We need to convert this to an angular velocity. Well, recall that one revolution is 2 pi radians. Okay? So there's 2 pi radians per one revolution. Multiply that by 30 revolutions per minute. Okay? And you're going to get an angular velocity of 30 pi radians per minute. Okay? So for this example, you have 30 pi radians per minute. Now, you may have to go and use your calculator to take 30 times pi to actually find the angular velocity. Okay? And let's just say that we are on a merry-go-round that maybe is 8 feet. Ooh, be careful. This is our mark for feet. We used a similar mark for minutes when we were looking at angular measures a while ago. But if I want to know the speed of this merry-go-round, I really don't have to do anything more than say I have 8 feet times 30 pi radians per minute. So now, grab your calculator, take 8 times 30 times pi, and that's feet per minute. And that will be the speed of the edge of your merry-go-round. Okay? So now you can take these formulas, go and try some of the homework in the next section that deal with angular velocity, linear velocity, and area of sectors and circles.